graphing systems, but now of linear inequalities. I'm going to bring it back to inequalities that we did last unit. Here I've got what would be, I'd consider in standard form. It's standard form because x and y are both on the same side. Over here I've got slope-intercept form. Different graphs or ways of being written tells you different information. For example, I think it's easier to find the x-intercept and the y-intercept off of this guy. I'm just, to find the x-intercept, going to cover up y and get x is equal to -8. So it's going to cross a -8, 0. To find the y-intercept, then I would actually just cross off the x and notice, hey, y is also a -8, so 0, -8. So those two spots, so let's see, here we go, 0, -8, and then, sorry, -8, 0, 0, -8. There's my 2 points for my graph. Since there's no line underneath it, I am going to dash that. And remember, we're going to shade on either the bottom or the top. What I do like to do to be a little bit more concrete is put in a point. Now 0 plus 0 is bigger than -8. Yeah, 0 is bigger than -8. Yes, it is. So I'm going to shade towards 0, 0. Whereas the one over here, slope-intercept form tells me the slope and the y-intercept. So I'll use the idea that slope is -1/1, and the y-intercept is going to be at 6. So I'll go down 1 to the right 1, down 1 to the right 1. There's a line underneath here, so it's equal to us, so I'm going to make it a solid line. And same idea, I'll put 0 in for both. Plus 6, so is 0 smaller than 6? Yes, it is. So I'm going to shade towards 0, 0 again. So same concept, but in a system, all that tells you is that you're going to graph 2 of these lines. Okay, graph them kind of nicely. So here, going back to the whole standard form idea, my x-intercept is going to be at 3, 0. My y-intercept, I'm going to have to divide. I'll get 0, -3/2. Okay, so I'm going down to about right there for my y-intercept. Here's my x-intercept. There's a line underneath it, so here we go. Now I am going to kind of color code this. Let's go yellow for the shading on this top one. I'll test 0, 0. So is 0 less than or equal to 3? Yes. So I'll shade that way. Okay, my second line here, 3/1, because it's in slope-intercept form. My y-intercept is -4. So go down to -4, and I'm going to go up 1, 2, 3 over 1, up 1, 2, 3 over 1, up 1, 2, 3 over 1. And I'm going to dash it here. Okay, I'm going to test this though. I'm going to put it here in blue. Maybe we'll go light blue. I'll put in 0 for y, and I'll put in a 0 in for x. So I'll end up with a 0 bigger than -4. It sure is. Now I am going to shade everything on that way. But here, blue and yellow make green, so where the green happens would be the solution to my system. So it's where the two shadings overlap. My yellow shading represented all the points that work for the top inequality. The blue was all the shadings, all the points that worked for my bottom inequality. The green is where the two overlap, and that's the solution to my system. So right here in the greenish area would be the area that works for both of those inequalities. So if I wanted to find a point that worked for there, I'd pick, like, say, -3 and 4, because -3 and 4 is about right in there. Should work for both the top and the bottom. Okay, I'm going to add a third. So whenever that occurs, that just means that you're going to end up graphing a 3. So let's start off with maybe, I don't know, red. So here in red, I go to 2. X equals 2 would be a vertical line, so I'm going to go straight up and down. And everything smaller than that would be. So don't go too crazy with your pencil in your shading, because you don't know where they're going to overlap yet. So y is equal to -3, so that's down here. There's a line underneath that as well, so it's solid. And everything greater. Okay, and then the last one here, I'll do that one here in maybe purple. It's in standard form, so go x is -2. There's one x-intercept. Okay, negative y equals -2, so y is a +2 is the y-intercept. Okay, dashed line. And I'll put 0 in for x and y. And 0 is bigger than -2, so I'm going to shade in there. So here it would be the little rectangle of my solutions, because the orange and the red and the purple all would have overlapped. Okay, kind of the same concept as we did before with graphing the line and shading. Now, what about this tells me to graph the line and shade? The fact that I've got these inequalities right there. So that is your systems of inequalities. Here, again, let's go one more. X is greater than 0. Now, x is greater than 0 is actually going to be the y-axis. So greater than 0 would be over this way. Let's go with cayenne. There we go. Nice little blue right here. Start at -1 and go up 2 over 1, up 2 over 1, up 2 over 1. Now, y is bigger than the line, kind of gives it away, if you remember that trick from before, but there's your blue line. You can test the point if you like. I did kind of in my head. Let's go with the green. Let's go +3, 1, 2, 3, and I'm going to go up 2 over 1, up 2 over 1, up 2 over 1, okay, with a line on it. Okay, so now the arrow y is less than, so less than, so it'd be less than. So the area where they all overlap, I'll grab a whole different color here because it's kind of confusing here, but I want where the purple, the blue line, and the green meet, so like right in there. So there you go. There's your systems of inequalities. Be very neat in your shadings and your lines. It's going to help you out deciding on where you should shade and whatnot. Again, if you got a pencil, go like really light, kind of dark, a little bit darker, and darken in that crazy area where they all meet.